Hello and welcome to Maths with Mr Amison. In this video we're going to be practicing how to calculate probabilities where the probabilities of a second event depend on the outcome of a first event. If you need to recap this topic, then please watch Mr Chowdhury's video. I'm going to start by showing you an example, then talking through it, then giving you the opportunity to copy it down and have a go yourself. Feel free to pause at any time. Alright, so in this example, there are 4 yellow counters and 5 red counters. 2 counters are picked at random, which means that when I pick the first counter, it's not put back in the bag or in the box or whatever. Both counters are picked at the same time. In a case like this, we can't assume that the first counter that is picked gets put back in. Okay, so if we had 4 yellow and 5 red, on the first pick, 4/9 of the counters are going to be yellow and 5/9 are going to be red, because there's 9 altogether. 4 of them are yellow and 5 of them are red. So we have a probability of 4/9 yellow and 5/9 red. Now, if a yellow one is picked and the second one was also yellow, that would mean that there would be one less yellow to choose from, because the first one that we picked was yellow, but also there would be one less counter altogether. So there would only be 3 yellows now left out of a total of 8. Or in other words, the numerator went from 4 to 3 because we lost a yellow counter, and the denominator went from 9 to 8 because we lost a counter altogether. However, if we picked yellow, the number of red counters would not change. There would still be 5 red counters. So we still have 5 as a numerator for red, but the denominator becomes 8, because even though we haven't reduced the number of red counters, we have only 8 counters left altogether. And you should be able to notice that the 3/8 and the 5/8, they add up to a whole one, because after we've picked a yellow counter, the chances of picking either a yellow or red, they add up to 1, or 100%. Now, if we'd picked a red counter first, the 5/9 probability here, the number of yellows would have remained at 4, but the number of counters altogether would have gone down by 1 to 8. The number of red counters would have gone from 5 to 4 because we've already picked one red counter, and the number of counters altogether would have gone down from 9 to 8 because we'd have already picked one counter. So you can see that again the 4/8 and the 4/8 add up to make 1 altogether. That will always be the case whenever you've got a split like this. If it's 2 splits or 3 splits, the probabilities will always add up to 1. Alright, so what's the probability of picking 2 yellow counters? Well, just like in the previous video on probabilities, on probability trees, the probability of picking 2 yellows is this option, then this option, and we multiply them together. 4/9 of the time we'll pick a yellow, and then 3/8 of the time after that we'll pick another yellow, so 4/9 of 3/8. So 4/9 multiplied by 3/8. When we do that, we multiply the numerators to get 12, multiply the denominators to get 72, so we get 12 over 72 as our probability. That does not need to be simplified, there's no need, because it doesn't say to simplify your fraction. Alright, copy this down, make sure you understand where that comes from, and then have a go yourself at calculating the probability of picking 2 counters of the same colour in the example on the right. Now you've had a chance to have a go, let's go through this. So there are 3 yellow and 5 red. So there's 8 counters altogether, 3/8 yellow, 5/8 red. If we had picked a yellow counter first, then the probability of picking a yellow counter Second, well, we've taken one yellow counter away, and we've taken one away from the total amount, so it should be 2/7. Therefore, we have 5/7 red because they add up to 1. Or in other words, we still have 5 red counters, and the number of counters altogether has gone down by 1 to 7. If a red one had been picked first, the probability of that was 5/8. So the probability of picking a yellow after you've picked a red, well, there's still 3 yellow counters to choose from, but there's only 7 counters altogether. So this should be 3/7, which means this is 4/7 because these 2 branches of the tree add up to 1. Or in other words, there are 4 red counters left after we've taken a red counter out, and there are 7 counters left altogether. The probability of picking 2 counters of the same colour. Well, there are 2 paths we could take for that, a yellow and a yellow. That would be 3/8 multiplied by 2/7, which is 6/56. Or you go 2 reds, which is 5/8 multiplied by 4/7, remembering to multiply those fractions. So both of those added together would give us the probability of picking 2 counters of the same colour, either red or yellow, it doesn't matter which one. So we get 26 out of 56 in total. Alright, so here are 4 questions for you to try. In each of these questions, picking 2 reds or not picking yellow or anything like that, the 2 picks are, the first counter is not put back. Therefore, the second probability depends on what is picked first. Alright, the first 2 are simpler questions, the third one's a bit trickier, the fourth question is a tricky question, so have a go. So here are the answers to those first 2 questions. We have 3 yellow, 4 red, so that's 7 counters altogether, so we get these probabilities. If we picked a yellow first, the number of yellows goes down by 1 to 3, from 3 to 2, sorry, and the number of counters altogether goes down from 7 to 6, so the denominator changes to 6. If we picked a red first, the number of reds goes down from 4 to 3, and again the number of counters in total goes down from 7 to 6, so we get these fractions here. So the probability of picking 2 reds, 4/7 times 3/6, gets us 12/42. Question 2, 3 yellows and 7 reds. This time we have 3/10 and 7/10, because it's 10 altogether, 3 yellows and 7 reds. The number of yellow counters, if we picked a yellow first, goes down from 3 to 2, the total goes down from 10 to 9. And the number of reds stays at 7, and the total goes down to 9. If we picked a red first, the number of reds goes down from 7 to 6, and the total goes down from 10 to 9 in both of these fractions. So, to double check, you can see that these 2 branches add up to 1, these 2 branches also add up to 1, and these 2 branches also add up to 1. So we know that this is right. So in this case here, 7/10 multiplied by 6/9 is the case, because the probability of not picking yellow, well, that's the same as the probability of picking 2 reds. So the probability of picking 2 reds, 7/10 times 6/9, to get 42/90. For question 3, I'm not going to go through the numbers on the probability tree itself, because I've gone through a few of those and you should be able to figure out where they came from now. But the probability of picking 2 different colours, we could either have yellow then red, which is 3/9 times 6/8, which is 18/72, or red then yellow, which is 6/9 times 3/8, which is also 18/72. So the probability of picking 2 different counters by those 2 paths would be those 2 probabilities added together, which is 36/72. For question 4, for 3 yellow and 5 red counters, it looks like this. The probability of picking at least 1 yellow, well, because all the probabilities add up to 1, this is the same as 1 take away the probability of picking no yellows. So if we can find the probability of picking no yellows, which is the probability of picking not yellow, then not yellow. 5/8 times 4/7 being 20/56. The probability of picking at least one yellow will be 1 take away that, or 56/56 minus 20/56, which is 36/56 altogether. Alright, thanks for watching. I hope you found that useful.